Why is isoniazid used for both active and latent TB? Have you ever wondered why isoniazid is a go-to medication for both active and latent tuberculosis? Let's dive into the details. Isoniazid is effective because it specifically targets the bacteria responsible for tuberculosis, known as Mycobacterium tuberculosis. It does this by inhibiting the synthesis of mycolic acids, which are crucial components of the bacterial cell wall. This unique action allows isoniazid to work effectively in different states of the bacteria. For those with active tuberculosis, isoniazid acts as a bactericidal agent. This means it kills the rapidly dividing M. tuberculosis bacteria. Isoniazid is a prodrug, which means it needs to be activated by a specific bacterial enzyme called catalase peroxidase. Once activated, isoniazid forms a compound with nicotinamide adenine dinucleotide. This compound inhibits an enzyme called INHA, which is involved in the synthesis of mycolic acids. By disrupting the bacterial cell wall, isoniazid leads to the death of bacteria during their active replication phase. Now let's talk about latent tuberculosis. In this case, the bacteria are in a dormant or slow-growing state, often hidden within granulomas. These dormant bacteria are less susceptible to many antibiotics. Here, isoniazid takes on a different role. It becomes bacteriostatic, meaning it inhibits bacterial growth without necessarily killing the bacteria outright. Recent research has shown that isoniazid may also help modulate the host's immune response. It can promote the differentiation of pro-inflammatory monocytes and protect immune cells from damage. This immune modulation is crucial for controlling the dormant bacteria that survive in granulomas. Interestingly, isoniazid can be activated not only by the bacterial enzyme but also by certain host enzymes. These include neutrophil myeloperoxidase and eosinophil peroxidase. This ability helps isoniazid penetrate the waxy granulomas where the latent bacteria resided, allowing it to exert its effects even when the bacteria are not actively dividing. In summary, isoniazid is used for both active and latent tuberculosis because of its dual action. It kills actively replicating M. tuberculosis by inhibiting mycolic acid synthesis and helps control dormant bacteria through its bacteriostatic effects and immune modulation. This comprehensive mechanism is why isoniazid remains a cornerstone in the treatment of both active tuberculosis and the management of latent tuberculosis infection, ultimately helping to prevent the progression to active disease. Always remember to consult with healthcare professionals for personalized medical advice regarding tuberculosis treatment.